Hello everybody, thank you for watching. This is our 2.8 video types of radiation. So in this video, we're going to learn what are the different types of radiation that can be emitted by unstable nuclei. So first off, let's quickly review what it means to be stable and unstable. From our last video, we talked about how unstable nuclei, we also call them radioactive because these nuclei will decay, break apart, or shoot out protons and neutrons. So they're unstable if they have a different ratio of protons and neutrons. Nothing really happens to stable nuclei, they just kind of exist and they're just really there. So we really care about the unstable nuclei. So what happens to unstable nuclei? We know that they emit, decay, and shoot out smaller particles in energy in many different forms. So this type of energy that is being emitted is referred to as radiation. And that's why we call unstable nuclei radioactive, because they can emit radiation. There are many types of radiation. We have some X-rays, we have alpha particles, we have light, we have beta particles, we have positrons, gamma rays, and even microwaves. If you take a look at this image right here, you can see that there is two types of radiation. There's non-ionizing and ionizing. The three that we are going to talk about in this class is alpha, beta, and gamma. So when we say ionizing radiation, we say that these types of radiations, they have enough energy to remove electrons from an atom and ultimately turning that atom into an ion. And if you remember from our previous videos, an ion is anything that has a positive or negative charge. So when we are talking about ionizing radiation, we know that there's enough energy to remove these electrons from our atom and ultimately turn them into an ion. So let's give it a scenario if we have two atoms that are next to each other. We have one very unstable nuclei, and we know that it's going to shoot out all these different particles. So these particles are going to be shot out and they're going to hit another atom that's right next to it, taking one of these electrons and just pulling it away. So before radiation, this is what happens to that atom. After the radiation, you can see because this electron is being emitted, this atom turns into an ion. So therefore, it's going to have uneven numbers of protons and electrons, and ultimately, it's going to have a charge. Since we said the three types of radiation that we're going to talk about is alpha particles, beta particles, and gamma rays, there is this nice chart that talks about each type of radiation, what it is, its composition, its isotopic notation, and the symbol. So if we're talking about alpha particles, we know that it's a particle. Its composition is just 2 protons and 2 neutrons, and this is what the isotopic notation looks like. It's helium with 2 protons and 4 protons and neutrons combined. The symbol is this Greek symbol, which is just alpha. For beta particles, we know it's a particle. It's actually an electron. So this is what the isotopic notation looks like. It's E with a -1 because we know that electrons are negatively charged and they don't really have a mass. So that's why we put a 0 right over there. The symbol for that is this Greek symbol beta. Gamma rays are a little bit different because they're not particles now. They're just kind of like waves. They're kind of like waves of light. And it's really hard to see them, but the isotopic notation looks like this. This is the Greek symbol gamma. It looks like this, and because it's not a particle, it does not have a number of proton, and it definitely does not have a mass because it's just a wave of light. So quick recap of things that we talked about in this video. We talked about unstable nuclei, what they are. We talked about what is ionizing radiation, and this chart right here is very, very helpful and contains a lot of information that you will need for previous material in this class. Thank you for watching.